Okay, so one of the main goals from today, or from these videos so far, is I want you to be able to identify an acid and a base in any reaction. Okay, in any acid-base reaction, I want you to look at the reactants. Okay, so we're identifying the acid and the base will always be on the reactant side. You'll never identify the acid and the base on the product side. They'll always be the reactants in a chemical reaction. So let's look at the first one. We have CH3NH2 and we have water. Now, to identify what our acid and our base is, we do need to look at the products, but we're not going to label the products as acid or base. We'll come back to the reactant side and label these compounds as acid or base. But to figure out who's giving the hydrogen, who's receiving the hydrogen, we have to look at the products. So on the product side, we have OH minus and we have CH3NH3. So if we go back to the reactant side, which one of these gave away a hydrogen? CH3NH2 becomes CH3NH3 plus. So it did not give away a hydrogen, it gained an H plus. Okay, see right here, the subscript went from 2 to 3. Water, on the other hand, has 2 hydrogens, and on the product side, it's just OH minus. So it lost an H plus, or it donated. Actually, I should write that. So which one is the acid? I'll write that in blue. It's got to be water. Anything that donates, remember a proton donor is an acid. So anything that accepts a hydrogen, here the thing that gained the hydrogen was CH3NH2, that is our base. Where are the lone pairs that receive the hydrogen? They will be on the nitrogen. If we drew the Lewis structure out, I meant to draw that in a different color. Let's do red. This is our base. If we draw out the Lewis structure for CH3, let's make sure we've got a lone pair here, NH2. We know nitrogen in any Lewis structure has 3 single bonds here, or 3 bonds. It could be a double or a triple bond. And it has a lone pair. And so there's that lone pair on nitrogen that's going to accept the hydrogen from water. Okay. Next reaction, we start out with OH minus and HPO4 with a -2 charge. So again, you don't have to start out with neutral compounds. In this first reaction, everything on the reactant side was neutral. Here we have 2 things with wildly different charges, a negative charge and then a -2 charge. Okay, if you're remembering what I was talking about earlier, we said OH minus is a very, very strong what? It's a very, very strong base. Okay, so we'll go ahead and label this the base, but let's make sure it's doing what we said. HPO4 becomes what? PO4 minus. So it gave away the 1 acidic hydrogen it had. It donated H plus. So that makes this the, I'm going to write it on top, acid. OH minus becomes H2O, so it accepted H plus. And that's why it's the base. Now remember, if we draw the Lewis structure for OH minus, we've got plenty of lone pairs here to accept that hydrogen from HPO4 2 minus. So again, an acid doesn't have to be a neutral compound either. Here, the acid had a -2 charge on it, okay? Last one, we have HCO3 minus, and we have water. What happens on the product side? HCO3 becomes H2CO3. So if we go from 1 hydrogen to 2 hydrogens, it gained or accepted an H plus. And water went from H2O to OH minus, so it lost or donated an H plus. So here water is our acid, and HCO3 minus is the base. Okay, where are the lone pairs on our base? If we draw out the Lewis structure, that might get kind of crazy. We typically don't draw Lewis structures out for a lot of ions, but the oxygen, okay, will have lone pairs, promise you. I've never met an oxygen that didn't have lone pairs. Carbon, we know, never has lone pairs. All right, so again, this is a main goal for these videos so far, is I want you to be able to identify acid and base in a chemical reaction. Another topic that we're going to hit on is conjugates. So what is a conjugate? The conjugates are the products in an acid-base reaction. So if you notice, when we label the acid and the base, we are only on the reactant side. Now we're going to learn how to label the items on the product side. But to tell you, when an acid and a base react, what they form, the products, the result, is a weaker acid and base. And to clarify how we know that, the acid that results from the base we call the conjugate acid. Okay, that probably just sounds really confusing. We're going to break this down. But the acid that results, so on the product side, so we're going to get one product that's going to be an acid, and it's going to be formed from the base, and we call that the conjugate acid. The base that results, so it's on the product side as well, so we're going to form an acid and a base. But the base that results from the acid is called the conjugate base of that acid. So let me get a drink of water. If you look at this reaction here in red and blue, we have some compound. We're just abbreviating B for base, and we're showing that it has a lone pair. So it can accept this acidic hydrogen on our acid, which is in red. And if we make this trade, so these lone pairs are going to grab up this acidic hydrogen here. What they form is B with an H. Notice that on this side our base was neutral. So when we add something with a positive charge to it, we end up with a plus charge overall. What's left over from the acid is A minus. And look, we have this bond here connecting our acidic hydrogen to A, which stands for acid. This is 2 electrons in that bond. And when A breaks off and goes over to the base, it leaves these 2 electrons with the rest of the molecule that's making up the acid. So that's why what's left over, we draw lone pairs on it. Because these 2 electrons in this bond connecting that hydrogen to the acid, those 2 electrons, again, they come over and they stay on the acid. Okay? So these are conjugate acid-base pairs. We've drawn lines here in black. We have the base on the reactant side, and after it accepts the hydrogen, look, when we come over to the product side, we have something that can act as a base. We have a hydrogen attached to a molecule. Anything with a hydrogen, it could act like an acid if that hydrogen is positively polarized. So this must be a polar bond. Okay, remember, you can't classify this as an acid if it's not an acidic hydrogen, okay? And then if you look at the conjugate base here, we have our acid, okay? It gave away a hydrogen and now it has a lone pair. That's all you need to be a base, right? You just need to have a lone pair. So it could go off and accept a hydrogen from someone else. So this is the conjugate base, and it was formed from the acid. And this over here that I'm circling or squaring is the conjugate acid, and it was formed from the base. All right, now let's practice this. So